Hello, this is 7.4 binomial theorem. So objectives expanding power of the binomial using the Pascal triangle, and also we can do the binomial theorem. So Pascal triangle, when you have a binomial powers not that big, we can still use a Pascal triangle. And then if the powers are very big, and then we might want to use a binomial theorem. So power of the binomial. A binomial is an algebraic expression with the two terms. In this section, we'll determine the pattern that exists in the whole powers of binomial expressions that will allow us to find relatively high power of the binomial without multiplying the binomial by itself numerous times. So to begin with, let's consider the following list of the power of the x plus y, which is a binomial, and then as a power 0, 1, 2, 3, 4, 5, so on. So 0 power is always 1, and the first power stays the same. The second power, which means x plus 2 square, x plus y square means x plus y times x plus y. And then when you FOIL, you get this. The cube means you multiply another x plus y. X to the fourth means you multiply another x plus y. And then as you notice that the terms are expanding, isn't it? So when you have 0 power, we got one term. First power, we got two terms. And second power, we got three terms. And third power, we got four terms. And fourth power, we got five terms. So which means fifth power means we got six terms. So your number of terms are always one more than the degree of the binomial. Having some background in algebra, we should be able to recognize the first powers of the binomial x plus y from the previous study. However, we'll use the patterns displayed above the continue, the least to higher power. First, starting with the binomial x plus y squared, let's consider the pattern of the variable on the right side of each equality. So as a first term of x is decreasing from the 2. So from 2, 1, no, 0, 0 power for x. As a y is increasing. So as a power of y is a 0, 1, 2. As a x, 3, 2, 1, 0. And then for the y is 0, 1, 2, and 3. Okay, so yeah, that's how you work with the binomial as a variable. In each expression in the one on the right, the first term has x with the same power as the power of the binomial, decreasing by one of each term moving to the right. For the variable y, the first term has no y term, but the power of the y increases by 1 for each term moving to the right until they reach the same power as the binomial. In general, for any power of the binomial x plus y, the variables will have the following pattern and with the power of the y reaches the end. Secondly, we need to find the coefficient of each term. So for relatively low power of the binomial, we can use a Pascal triangle to determine the coefficients. The following is the first 8 rows of the Pascal triangle, where each row starts and ends with a 1, and each other number is found by adding two numbers directly above it. So I'll show you how to get it, okay? So starting with the 1, and then I need you to put down the 1, 1, and then always outside number is a 1. In order to get the middle number, I need you to add this 1 and 1 together. So 1 plus 1 is a 2, but I want you to put down here. And then you got 1. Starting with the 1, and then adding with the 1 and 2, which is a 3. And then I need you adding with the 2 and 1 to get 3. And then 1. So let's notice what? 1 term. And this is 2 terms. And 3 terms. And then 4 terms. So I want to get up to the first 8 rows, okay? So we have a fourth row right now, right? Okay, so 1. Now 1 plus 3, 4. Now we have 3 plus 3, 6. And then we have 3 plus 1, which is a 4. And then 1. So I got 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, and 1. So I got 1. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. And 5 plus 1, 6, and 1. And then 1, 7, 21, 35, 35, 21, and 7 and 1. I think we got all 8 rows. So you can keep continue. So using the variable pattern along with the coefficient from the proper row of the Pascal triangle will expand the power of the binomial. So write the expanded expression of the each binomial power using the Pascal triangle. So when you have a negative sign in the middle, do you see negative sign? And then the signs are always alternating. So first term is a positive, second is a negative, so always the second term is a negative. So we have 7th, okay? So what I needed is this is going to be the coefficient, okay? So I have a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and 1, 6, 15, 20, 15, and 6, and 1. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4. Yeah, so I need this coefficients. So with the coefficients, okay, so as you notice, is a 1 times x is a 7th power, y is a negative, and then plus, now 6 times, because from the 6 here, okay, 6 times x is a decreasing, y is a start increasing, first power, we don't have to put it though. Sorry about this, negative y. Sorry about that. So y is a negative y. And then, so every even terms are positive, okay? Every negative, and the odd terms are positive. So plus, next one is 15 times x is a fifth, and then negative y is a square. And then plus, and then 20, and the x is a decreasing, and then y is a increasing. And then another number is a 15, x is a decreasing, y is a increasing. And then 6, x is a decreasing, y is a increasing. 5, sorry about that. Plus, and then the 1 of x is, hold on a second. That's not right. Okay, hold on a second. I'm sorry. I'm messing it up. I think I need to get one more. So 1, 2, 3. Yeah, I still have a 7th terms, okay? So I need to get 8 terms. Alright, sorry about that. So I need to go one more. So I got 1, 7, 21, 35, 35, 21, and 7. And 1. Yeah, that's what I need because it's a 7th power. Sorry about that. So now I have 1 times x is a decreasing, y is a increasing, but there's no y term for this one. And plus, sorry, yeah, I'm not using this one. So now I'm using this coefficients, okay? So I'm using 1, then now 7. X is a decreasing, y is a increasing. And 21. X is a decreasing, y is a increasing. 35. X is a decreasing, y is a increasing. Another 35. X is a decreasing, y is a increasing. And then next one, 21. X is a decreasing, y is a increasing. 7. X is a decreasing, y is a increasing. And then 1. X is a decreasing, it's 0 power, we don't need to put it. And then we got y to the negative y to the 7th power. And then all the second term, which means this second term, I mean the odd term, is all negative, which means even terms are all the positive, okay? So in here, so 1 times x to 7 is x to 7, and then this negative comes out, okay, because positive negatives are negative. And then you got 7x to 6y. And then this negative become positive because it's square. So positive 21x to 5th y squared. And negative And then because this is a negative is third power, so you got 35x to the 4y cubed. And then this is negative is even power, which is a positive. So 35x cubed y to the 4. And minus this negative becomes negative because of fifth power. So 21x squared y to the fifth. And then positive 7x y to the 6 and negative y to the 7. So this is it. So what do we use for the Pascal triangle? It's going to be our coefficients. So now we have a 2x plus 3y to the fifth power. So 2x plus 3y to the fifth power, which is we need the 6 terms. So I think I'm going to use the this ones. 1, 2, 3, 4, 5, 6, right? Okay. Alright, but this time not just the x and y. So alright, so I'm using 1 times of 2x to the fifth power. And then the next one is 5, because I'm using this one. 5 times 2x is a decreasing power, but 3y is increasing. It's the first power. Next one is a 10. 2x is a decreasing, but 3y is a increasing. Another 10. 2x is a decreasing, and that's 3y is increasing. And then next one is a 5, and 2x is a decreasing, and 3y is increasing. And then next one is 1. 2x is decreasing at 0 power, so 3y to the fifth power. But this time, actually, it's not a power of x. It's power of 2x and 3y, right? So we have to do those. So I got 1 times 2 to the fifth is 32x to the fifth. And also second term is 5. 2 to the fourth is a 16x to the 4 of 3y. And then third term, 10 times 2 to the cube is 8x cubed. And 3y squared is a 9y squared. And 10 times 2 squares of 4x squared of 27y cubed. And plus 5 times 2 times 2x times. And 3 to the 4 is 81y to the 4. And plus 1 times 3 to the fifth is 243 y to the fifth. Okay. Now I'm going to simplify one more time. X to the fifth, and then 5 times 16 times 3 is 240 x to the 4y. 720 x cubed y squared, and 40 times 27 is 1080 x squared y cubed, and 10 times 810 xy to the 4 plus 243 y to the fifth. So this is a final. So make sure that you also need to square the number and then variable. Power. I have a c, x squared minus 5 to the fourth power, okay? So I'm using the Pascal, so I got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So I think I'm going to use this because it's the fourth power. Okay, so 1 times x squared to the 4 plus 4 times x squared is a decreasing, and then negative 5 is increasing. Another 6, x squared is a decreasing, negative 5 is a increasing. And then 4, x squared is decreasing, and negative 5 is increasing. And then last one is 1 times, now x squared is decreasing, and then negative 5 is increasing. So since this is a middle is a negative sign, okay, so even terms are always negative. So first one is 2 times 4 is 8, and plus negative actually. So, and then the 4 times negative 5 is negative 20 x to 6, and then it's going to be plus, and then we need to multiply negative 5 squared is 25 times 6, which is 150 x to 4, and negative And 5 to the negative 5 to the cube is negative 125 times 4, which is 500, and x squared, and then and plus 625. Negative 5 sub 4 is, yeah, that's all. Now, binomial theorem. Using Pascal triangle is helpful or for the relatively low powers of binomial. But as we increases the power of the binomial, we wish to expand. We use the factorial and the binomial theorem. So we need to talk about factorial. So factorial means n is a positive integer, and factorial written as n factorial of this, which is the product of the all positive integer from the n down to 1. So n factorial means you start from the n times n minus 1 times n minus 2 all the way to 1. But remember, 0 factor is always equal to 1. Because if you consider 0 factor is a 0, and then all the product becomes a 0, which is that's what we don't want. So 5 factor means 5 times, 4 times, 3 times, 2 times 1, okay? Which means you might have a factor in your calculator, so please find it too, okay? So 5 factorial means we have 120. 8 factor means 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. So 8 factorial means 40,320. Okay, so as we move toward the binomial theorem, we will calculate some rational expression involve the more than one factorial. So for any two non-negative integer n and k, with expression nk read as n choose k, defined as nk. So n choose k, which is this is same as combination. So c n choose r, which is k. Okay. So calculate each of the following. So you gotta use as you do the 4 factorial of the 4 minus 0 factorial with a 0 factorial. So use a calculator. So 4 factorial, 4 minus is a 4 factorial and 0 factorial, which is it's going to be 4 factorial over 4 factorial is 1 times 1, which is 1. This cancels out. Alright, 4 factorial, you got 4 minus 1 factorial and then 1 factorial. So you got 4 factorial, 3 factorial, and 1 factorial. 1 factor is also 1 too. So 4 factorial means 4 times 3 factorial over 3 factorial times 1, and then equal to 4. 4 choose 2. So 4 factorial, 4 minus 2 factorial, and 2 factorial. So 4 factorial, 2 factorial, 2 factorial. So 4 factorial, 4 times 3 times 2 factorial. And then 2 factorial times 2 times 1. So 2 factorial cancel, 2 goes 4 twice, equal to 6. 4 factorial, 4 minus 3 factorial, and then 3 factorial, which is 4 factorial, over 1 factorial and 3 factorial. So 4 factorial is 4 times 3 factorial, 1 times 3 factorial, cancel, you got 4. So now 4 factorial over 4 minus 4 factorial as a 4 factorial. So 4 factorial over 0 factorial, 4 factorial, which is a 1. So 14641, which is it's the same as what we find the coefficient as a Pascal triangle, okay? So example 4, use a binomial theorem to write out the first 5 terms of the expanded. So yeah, it's going to be a lot. So since we have a degree of 10, we have to have 11 terms. I think that's too much. For the forms of each of the following expression. So you're starting from 10 choose 0. And then this x is always 10 minus 0. Subtract that. And then y is the same as the power of 0. And then next one is 10 choose 1. X is 10 minus 1, and the y is the power of 1. 10 choose 2, x is 10 minus 2, and then y is the second power. 10 choose 3, and then x is a 10 minus 3, y is a cube. Now 10 choose 4, x is 10 minus 4, and then y is the fourth power. So 1, 2, 3, 4, 5, and then we can keep going same way. Alright, simplify. 10 choose 0 means 1. To the x to the 10th power, y to the 0 power is 1. 10 choose 1 means a 10. And the x to the 9th power, y. 10 choose 2, which is 10. You can use a combination. I got 45. And then I got x to the 8 and then y squared. And then 10 choose 3. I got 120. And x is a 7th, y is a cube. And then 10 choose 4. I got to 10. And then x to the 6, y to the 4. And then so on. This is how you simplify. Now we have a 13th power. So starting with 13 choose 0. X is a 13 minus 0 power. And then negative 2y to the 0 power. Plus. Now 13 choose 1. We have x is 13 minus 1 and then negative 2y to the first power. 13 choose 2. X to the 13 minus 2, negative 2y to the second power. 13 choose 3, which is x to the 13 minus 3 and negative 2y to the third power. 13 choose 4. X is 13 minus 4 of negative 2y to the fourth power. And then so on. So because we're only looking with the first 5 terms. Okay, 13 choose 1. 13 choose 0 means 1 times x to the 13th power times negative 2 y 0 power is 1. 13 choose 1, which is 13. And x is a 12 of negative 2y. 13 choose 2, 78. X is 11th power and negative positive 4y squared. 13 choose 3, which is 286. X is 10th power and negative 8y cubed. And 13 choose 4, 715 of x to the 9th power and then positive 16y to the 4 and then so on. Simplify further. So x to the 13th power minus 26x12y 78 times 4, which is 312, x11y squared, negative 286 times 8 is 2288, x to 10y cubed, plus 715 times 16 is 11,440, x to 9, y to the 4. And then you can get further if you want, okay? That's what they needed. Alright, I think that's all for the binomial theorem. Okay, thank you for listening.